Hey, we have here to another integral from MIT Integration Bee 2010. This was problem number 2. We're integrating from 0 to pi over 2 sine cubed 2x cos x dx. Okay, what I want to do here, I'm just going to do the most straightforward thing. We're going to first look at the double angle formula for sine. So if we have sine of 2x, we can write this the same as 2 sine x cos x. And then notice this is cubed, so let's just put our cube on this. So then rewriting this, we'll cube our 2. So 2 cubed is 8. And we're going to have sine cubed x cos cubed x. And let's take this and we'll plug it right back in here. Okay, so on the rewrite, I'm going to take my 8 and just bring it out front of the integral. We're going to have sine cubed x. And I'm going to multiply this cosine cubed x times cos x. And that's going to give us just cosine to the 4th x dx. From here, this is a case where we like to set up a u substitution. What I'm going to do is, because we have an odd power here, I'm just going to rewrite this a little bit. So what I'm going to do is I'm going to split this out. We're going to have we'll have a sine squared x. We'll write as sine squared x times sine x, and we'll write this over here. And then this is going to allow us to use the identity and rewrite this as 1 minus cosine squared x. Then when I do my u substitution, what's going to work best, I think, is if we do u equals cosine x, then du is going to be minus sine x dx. So what I'm going to do is I'm just going to create a minus sign right here to match this. So we have our du right here. I don't want to change it. Let's just bring a minus sign over here for now. So now let's make our substitution. I'm going to plug a pi over 2 in here. Cosine of pi over 2 is 0. And then plugging a 0 in, and we have cosine of 0 is just 1. Then we're going to have our 1 minus cosine squared x. This is going to be 1 minus u squared. Cosine to the 4th is going to be u to the 4th. And this part here is just our du. Then I'm going to take this minus sign here and I'm going to use that to swap my bounds. So instead of going from 1 to 0, we'll go from 0 to 1 here. Then let's just distribute in this u to the 4th. So we're going to have 8 from 0 to 1, and this is going to be u to the 4th times u to the 6th du. And now we're in good shape for the power rule, so we'll have our 8 out front. This is going to be u to the 5th over 5, minus here we're going to have u to the 7th over 7, again from 0 to 1. But when we evaluate this, we don't have to worry about 0, because when we plug zeros in, we're going to get all zeros, and that part's going to go away. So when we plug a 1 in, we'll have our 8 out front, and we're just going to have 1 over 5 minus 1 over 7. When we get a common denominator, we'll make our common denominator 35, and then we'll be just doing what we'll have here in the numerator. We'll have 7 minus 5, and so this is going to be here. This is going to be 2 over 35, so we multiply this out. For our final solution, we're going to have just 16 over 35. So that's it, just kind of a straightforward trig integral today. So we'll stop it there. Thanks everyone for watching. Please like and subscribe. Have a great day.